All right, so we got another demo. We're talking about standing sound waves. And standing sound waves are essentially waves that are constantly moving back and forth. And a really great way to demonstrate this is this boom whacker. Boom whacker is something you may have played with in, like, I don't know, preschool or early elementary school in music class. And all a boom whacker is it's a closed tube, or it's an enclosed tube, and it allows air molecules to like slosh back and forth whenever it's disturbed. So if I hit it, it puts out a frequency because the air molecules are moving back and forth. Now, when I grab a different length one, we have a speed of sound, velocity equals frequency times wavelength. The wavelength is going to be shorter, so the frequency is going to be higher. So when I hit a shorter tube, it makes a higher pitch. So that is the concept of a standing sound wave. Now, there is a cool consequence of this. Most instruments work like open tubes, but some instruments, like the clarinet, work as an open-closed tube. And an open-closed tube just means that one end of the tube is capped. And when I cap one end of the tube, this is now not open all the way through, and that actually changes what's happening inside with the standing sound wave. So in the next section of notes, we're going to talk about standing sound waves. We're going to talk about open-closed tubes, open tubes, and closed tubes, and essentially what's happening with the air pressure through those tubes. Now, if you recall back to the last lab, the determining the speed of sound lab, we put a pipe in water. Well, water acts like a barrier, and that made it a closed tube on one end and open on the other. And I said you had to do something for that. I said you take whatever that length of that tube was and multiply it by 4. Because just by having this end on it, so this was our pitch before, by adding this closed end to it, we actually effectively double the length of the tube. And if you're saying that sounds familiar, you're probably not. We have the same pitch, roughly, being put out by both of these tubes simply because I capped one end of it. So that is the difference between an open and an open-closed tube, and we'll take a look at that in the next section.